I remember thinking when I first saw Finding Nemo that Nemo's dad had to go a really, really long way to find him, all the way from the Great Barrier Reef 1,500 miles to Sydney, sometimes swimming along at a constant speed, sometimes racing to escape from predators, and sometimes dodging jellyfish with great agility. Now, as an engineer, I think surely we can learn from millions of years of evolution and design our own swimming robots that can swim fast and swim slow and change direction very efficiently, like Nemo's dad. There'd be a certain beauty with being able to monitor our marine life, 25% of which lives on coral reefs, with a new generation of efficient swimming robots inspired by that very marine life. When Nemo's dad flicks his tail from side to side, it makes him go forward. The timing of those tail flicks is very important. It's exactly like being on a swing. We've all seen that poor child, Jimmy, that just can't get their legs out at the right time and is left floundering near the ground, working very hard, while his friends swing effortlessly up to the skies, getting the timing just right. If I make a robot fishtail from some fish-like materials and flick it back and forth at just the right time, it'll swim forward efficiently, like the friends on the swing. But if the timing is off, it'll be working hard like Jimmy and not really getting anywhere. But we know that Nemo's dad can swim at many speeds, so what's the trick? He's able to tune the stiffness of his tail using muscles and tendons so that he can swim at many different speeds while staying efficient. It's like if I lengthened or shortened the lengths of the swing, it'll change how high the swing goes, and it'll also change this timing that is needed to move it efficiently. The height of the swing is like the speed of the fish, and the length of the rope, the stiffness. For my PhD, I've used this principle to design and make a swimming robot using pressurized tubes to tune the stiffness of the tail. They act like Nemo's dad's tendons. By pressurizing these tubes, I stiffen the tail, which means it's more efficient to swim fast, and by reducing the pressure, it's more efficient to swim slowly. In my experiments, I've found that I've been able to triple the range of efficient swimming speeds. The next stage for me is to use this technology to further increase efficiencies in ways that fish cannot. And maybe one day, my little robot will make it all the way to P. Sherman, 42 Wallaby Way, Sydney. Thank you.